Welcome back to the Edgeverse TechCast, a one-stop shop to learn all about NXP software enablement. And we're happy you are here. You are listening to the fourth and final episode of our CRA week. And for those new to the TechCast, I'm still one of your hosts, Kyle Dando.
And I'm Bridgette Stone. Over the past 3 episodes, we've covered risk assessment, security by design, and proving compliance. Today, we complete the journey with step 4, maintaining conformity over a product lifecycle.
Yeah, Bridgette, this final step, it really clarifies how CRA compliance doesn't end when your product ships. Devices need to stay in the field for years, and the manufacturers need to ensure they remain secure and compliant over time.
And for this final step, we're joined by several members of the NXP CRA and product security team. Welcome, everyone.
Hello. Hello.
All right. What a group we have. We have 3 speakers joining us. Bridgette, we are really getting an audience now, so that's great. Bridgette, this has been a great week. Our listeners have gained access to the NXP experts, helping customers and internal teams manage long-term product security and CRA readiness. I can't wait for the 3 of you to help us cross the finish line strong.
By the end of the episode, we hope you will have learned what happens after your product ships and how to maintain CRA compliance throughout a device lifecycle. Let's get started, guys. So Asim, you're up first. Once a device ships, CRA compliance doesn't stop. Devices can remain in the field for years, sometimes decades. What are the biggest challenges manufacturers underestimate when trying to maintain security and CRA compliance over the full product lifecycle?
Thanks, Bridgette. There are several challenges that manufacturers routinely underestimate. The first I wanted to touch on is architecture drift over time. One of the hardest CRA challenges is keeping old designs secure. As products age, early choices like crypto, boot chains, update mechanisms, they all outdate. What was secure at launch may not be hard or even impossible to patch years later, and retrofitting modern security onto legacy hardware becomes quite a nightmare.
So security decisions made early can impact the product for its entire lifetime.
Exactly. And the second challenge is maintaining those secure configurations. They say the toughest part of CRA isn't adding new bells and whistles, it's keeping them secure for the entire life of the product. Devices in the field drift, settings change, old images stay unpatched, and dependencies move on. CRA requires secure by default forever. It's not just a one-time deal. That long-term configuration discipline is where most companies unfortunately stumble.
Yeah, security becomes an ongoing operational responsibility, not just a design milestone.
Yeah, that's correct. The third underestimated challenge is what we like to call crypto agility, and you'll hear that term quite a bit. But crypto ages fast. Algorithms weaken, key lengths get outdated, some of the protocols evolve. The CRA expects the state-of-the-art protection over time, which means devices need crypto agility built in, things like rotatable keys, updatable algorithms. Without that, products just become obsolete long before the hardware wears out.
Yeah, especially for those products expected to operate for 10 to 15 years.
Right. Documentation is another commonly overlooked item, Bridgette. Documentation never really stops. Every patch, the dependency change, vulnerability needs to be tracked. SBOMs, risk assessment, update logs, they all must stay current for every supported version of software that is bought into the market. Most teams underestimate how quickly documentation debt piles up. Finally, sustaining long-term processes. CRA, as we've mentioned, isn't a one-time certification. It's a long-term operational commitment. You'll need vulnerability monitoring, and we have an established PSIRT, which Lewis will detail later. So it's not just engineering work, it's organizational muscle that has to be in place and last for years.
Those are excellent points, Asim. There's just so many things for our customers to consider. So that's great section, but let's keep going. Here's another difficult question that we hear manufacturers face. They ask themselves, how can I make my product's architecture future-proof? but has to remain secure while receiving critical updates. As you've mentioned, staying CRA compliant isn't just about having the right mechanisms when the product first ships. It's about making sure those mechanisms still work reliably 5 or 10 years down the line.
Thanks, Kyle. Yeah, that is a tough question. There are a few elements to consider, starting with secure by design hardware, as my colleague Mark introduced in the second episode. Future-proofing really starts at the silicon level with something like NXP's EdgeLock Enclave. You get a hardware-isolated security domain that anchors secure boot, key storage, crypto operations, really the works. That means your secure by default baseline doesn't erode as the product ages and evolves. Secondly, building a robust over-the-air OTA strategy is essential. CRA compliance is all about long-term patchability. Devices will need signed updates, rollback protections, and an architecture that supports reliable OTA. We offer processors with secure boot chains, authentic image verification, and EdgeLock to go support that Julien will expand on later. So manufacturers have that foundation they need to deliver updates for the entire life of the product.
Great answer, Sim. Now, you did mention software bill of materials or SBOMs at the beginning there. So how is this critical in helping customers keep track of CRA compliance?
Yeah, that's correct, Kyle. The manufacturers must use software stacks that are SBOM friendly and maintained. A big part of staying compliant is keeping a clean, accurate SBOM over time. Now, that's only possible if your software stack is transparent and well maintained. The good thing is NXP's BSPs make this easier because all the components are documented. That helps manufacturers track vulnerabilities and keep evidence up to date.
All right, great job on SBOM. You also talked about how crypto is very difficult to sustain. Can you talk about that?
As I mentioned, crypto ages faster than hardware, so devices need the ability to upgrade algorithms over time. Prioritizing crypto agility is going to be important. That's another thing that we are really preparing for. NXP supports crypto agile boot and key management architectures as a leader in post-quantum cryptography. So as PQC standards solidify, manufacturers using NXP platforms will be able to transition smoothly.
Really great information there, Asim. You have set clear priorities to help our customers plan to remain CRA compliant for years. Now let's have Julien and Louis jump in to clarify more details on how customers can solidify their plans.
Julien, one critical lifecycle milestone is manufacturing. What are the key security challenges at this stage?
Hi, everyone. So indeed, CRA mandates that products are sold on the market with a secure by default configuration. This security configuration is enabled at device manufacturing. That's where the credentials for protecting the software of the device are installed, and that's where the identity of the device, which is used to securely connect the device to the network, is installed. So the challenge is how to protect the installation of those credentials, especially when the manufacturing of the product is delegated to one or to several contract manufacturers.
And how does NXP's EdgeLock to go help with this?
So EdgeLock to go is a cloud service for securely provisioning devices. The benefit of using EdgeLock to go is that the generation and installation of the credentials into the product is centralized and managed by our cloud service and is not delegated to the contract manufacturer. This means an OEM does not have to implement a complex security infrastructure on its own and has less dependency on its contract manufacturers regarding the security configuration of the devices. In the end, this helps reduce the attack surface, which is an important point to achieve CRA compliance.
After manufacturing the device, it is important to maintain its security configuration to keep device trust intact throughout its entire operational life. How can services like EdgeLock to go help OEMs continuously strengthen device trust across global fleets?
Right. Asim has explained how this maintenance topic is important in the context of CRA. But the challenge for OEMs is how to apply these updates securely. The EdgeLock to Go service can help protect the software update process by protecting the connection between the device and the update server, and also by protecting the software deployed on the devices. EdgeLock to Go will make sure that the new software is correctly signed and authenticated when it's installed on the device. Another important point of the maintenance process is to refresh the credentials, so the cryptographic keys and the certificates, to ensure they are always correctly protected. Credentials like certificates have a validity period and must be renewed to keep the connections with devices secure. Here again, the EdgeLock to Go service can take care of this renewal process so that OEMs don't need to implement this process on their own. This is also very interesting in the context of post-quantum crypto that Asim has mentioned. A service like EdgeLock to Go is very valuable to achieve crypto agility, as it can really simplify the deployment of new crypto schemes and credentials into devices which are already in the field. So for the device manufacturers, having a service like EdgeLock to Go is really a peace of mind, and it makes it easier for them to pass compliances like CRA.
Julien, that was a perfect application of NXP's EdgeLock to Go. It helped me understand how it helps customers meet those CRA requirements for both manufacturing and field updates. So great job. Now we're on to the final piece of the plan, and that is oversight and governance. So Louis, will you share how our listeners can help their own companies better monitor and react to a product's CRA compliance? What does it take to build a truly resilient security organization?
Great question. Thanks, Kyle, for having me on, and Bridgette as well. Let me start by first saying, first and foremost, products must be designed to be secure throughout their lifetime. As many have mentioned in the previous podcast, it means having a thorough security engineering design and building sufficient headroom. However, as we all know, there's no such thing as 100% security. So the question is not if, but when security vulnerabilities will be discovered in a product. So therefore, manufacturers, as Asim mentioned, it is critical to have an established PSIRT. Let me take a few seconds to explain what a PSIRT is. PSIRT is short for Product Security Incident Response Team. In a nutshell, a PSIRT is a dedicated cross-functional function that is responsible for receiving, analyzing, prioritizing, and coordinating the response to security vulnerabilities affecting the company's products in the marketplace. As a well-established PSIRT, we comply to the different standards and often follow industry standards frameworks such as FIRST. FIRST stands for Forum of Incident Response and Security Teams. Our PSIRT at NXP has been in place since 2008 and is well established with processes in place that are regularly audited and externally certified. We believe having a PSIRT is critical, and every manufacturer should be thinking about having one. If they don't, manufacturers should be thinking about how to react to different vulnerabilities. You may have zero-day vulnerabilities come in, and those could be high-profile vulnerabilities. Having these processes in place and knowing how to react is very crucial.
Okay, so as you said, Louis, companies should establish their own PSIRT in order to have that strong operational backbone to monitor their own long-term product security, just like NXP does.
Exactly. So back to your original question, a truly resilient organization is built by treating product security as a long-term product and a business capability, not a one-time compliance exercise. From a PSIRT and CRA perspective, resilience starts with secure by design and secure by default products, with vulnerability handling embedded across the entire product lifecycle. This requires institutionalized vulnerability management, including coordinated disclosure, predictable remediation, and sustained support and update commitments that extend well beyond the initial product release. Equally important is organizational continuity. A stable PSIRT mandate, executive sponsorship, and cross-functional ownership spanning engineering, legal, compliance, etc. Essentially, buy-in from everyone within the company is crucial. Finally, long-term resilience depends on ecosystem trust. Examples, communication with customers and partners, regulators, authorities.
All right, Louis, let's go deeper into the processes that manufacturers should adopt beyond just having the PSIRT that you just outlined. So CRA requires them to manage vulnerabilities throughout the product lifecycle. What are the core processes that a company should have in place to meet those obligations year after year after year?
Great question, Kyle. So some core processes that come to mind. First, manufacturers must maintain a vulnerability intake and discovery process that can receive reports from different sources such as customers and partners, third-party vendors, external security researchers, and lastly, internally found security vulnerabilities. These can be vulnerabilities found during the development phase and new products that may impact products in the marketplace, as an example. Second will be a process in place to perform structured vulnerability triage and impact assessments. Based on the assessment, a manufacturer needs to determine the best way to remediate the vulnerability. This may include security patches, mitigations, and configuration guidance, for example. A third process would be to communicate to customers and partners and also ensure proper coordination is in place. When more than one vendor is involved, what is known as multi-vendor coordination. And lastly, the new obligation to manufacturers requires notifying NISA and national CSIRTs of actively exploited vulnerabilities and severe incidents.
Excellent. All right, Asim, Julien, and Louis, you guys did great. So let's recap our CRA week as a whole. We started with step 1, which was risk assessment. In a nutshell, that means you need to take the time up front to understand the potential threats to your product. Then we stepped into step 2, which was security by design. And that is make sure that you add security into the architecture and design stages at your company. It needs to have the same priority that you've been giving all along to power, clocks, peripheral, and software development. Then we talked to step 3, which is proving compliance. Carlos helped us understand how a product's CRA classification dictates the necessary testing and reporting that's required. And step 4, we covered today. How do you maintain security over the full product lifecycle? You need to know that products can no longer be shipped without all the things that our guests today outlined. You need to support them through the lifecycle in the field and with their customers.
Yeah, Kyle, CRA isn't a one-time certification. It's a long-term commitment that spans engineering, manufacturing, and organizational readiness.
To Asim, Julien, Louis, and the entire CRA team, thank you very much for sharing your expertise during this CRA week.
Thank you, Kyle and Bridgette.
Thank you.
Thanks.
We really had fun with you this week. And to all of our listeners, thank you for joining us during CRA week. And if you missed an episode, we encourage you to go back and listen to the full series.
And until next time, keep assessing, designing, and certifying your products for the CRA. And we'll catch all of you on the next Edgeverse TechCast.